Oh, I missed the timer. What's up, guys? Let's get this going. Happy Saturday, everyone. I think I've got everything good. I hope everyone's having a fantastic Saturday. I am just getting the lab booted up here real quick. Kids were taking a little bit longer than I anticipated. Go to bed. Let me grab something here. There. Let's see. Let me come over here. We need to do a quick run on this real fast, but I need the attack box IP. There we go. Just preemptively add an hour to it. All right. Let's see. And let's go run this over in the studio real quick. We can just seed everything. All right. Cells in red. There we go. They should get us a nice clean pickle file to use for testing out the exploit agent, which is coming along. I'm so excited. So currently we're working on this part right here, the step processor, more or less. Well, actually, it's kind of like this whole loop right here. The step processor, I think, is... I gotta remember, because I haven't worked on this code since last week. Apologies for missing Tuesday night stream, by the way. What happened on Tuesday night? I was doing report writing this week. That's what it was. And I didn't actually go to bed Tuesday night. Nope. I just stayed up all night and was working on that report and pretty much barely got it finished by Friday. I was so rusty at writing reports. I had not had to write one in so long. It was just a beat down.
Back, baby.
Oh, it's that cute. Why'd he come in here? Just ban you fast. Hey, Dan, what's up, man? Dan the man. I didn't even see his other message. I don't know what he posted in there. That's all right. We'll just ban him. Let's go check in and see. Okay, we got Enum going on. Yeah, pretty good, man. I had a pretty decent day. Actually, I went to. My wife is real big into musicals, so last night we went and saw Lion King up on the theater stage. It was really good. It was surprisingly good. I was like, Lion King. I have fond memories of it. I was worried they were gonna mess it up because I've seen some other shows where like they really brutalized it. Like I saw this reimagined version of Oklahoma that was just absolutely an insult to call it insult to dumpster fires to call it a dumpster fire. It was so bad. There was like a freaking salmon run of people leaving the show at the intermission for Oklahoma. But this one was really good, and so if it ever comes back, I want to take the kids to it. I think they'll have a great time. All right, let's see here. Did this one finish? Go check it real quick. We got through the exploitation agent, then we know it finished. It did. Sweet. Actually, did it? Or did we get a... Or is it still running? Oh, now it has finished. Which this should update here in just a second. There we go. Dude, actually, look at that. It actually started executing the first step in it. Oh, freaking sweet. I am so excited to be working with this. Let's go see. Let's go take a look at the exploitation issue, because honestly, I don't even remember where I left off. This was a beatdown of a week. So Tuesday night, I didn't even go to bed. I stayed up. I worked on the report for a couple hours. I play a game for a couple hours. I work on the report for a couple hours. I go back and forth. Until finally, I was too tired to, like... Actually, I think I stayed up till, like, I don't know, I stayed up all the way clear through the next day. So I was up for like 36 hours or something. And then I crashed out for like 10 hours straight. Let's look here at the exploit agent. My kids are in Florida with their family, so I have a ton of free time. Oh, nice, dude. This is awesome, though. It looks like we might have got all the way through the step revisor, because that's where we actually had the end node coming in. So if we compare this to what we've got here, step update, analyze, back to this. This was kind of like the idea here. Looks like we got all the way to the revisor. So yeah, because what should happen here is the planner. Actually, this is where the loop is going to happen. The planner is just like the initial entry point to this loop. These ones right here are going to start entering a loop phase right here. So let's go look at the trace real quick and see kind of what came back. All right, let's see. What do we got here? So there's all of our data. What's our raw input? Hold on, where's our output though? There we go. Wait, what was the... Where's the prompt though? I'm surprised I'm not seeing this thing. That's our raw input. Default? Ah, there we go. Now we're talking. Here was our system prompt. Sweet. There's our system prompt, there's our human prompt. And then what was our output from this? Alright. We'll suggest viable exploits. It gave 3 viable exploit paths. So upload a PHP web shell to panel, exploit the file upload functionality to PHP code via FAR file, and others. Okay, cool. So we got 3 suggestions. That's what we should have. We're going to hit the router. Next thing is going to go to the step planner, where it should go through and actually give us like each of the individual steps. Let's see, our step processor here. Oh, actually, I take it back. Yeah, because our step planner... Let's go take a look at the code real quick. So like I said, I have to refresh myself on this. I probably should start just working on this off to the side on Friday nights. Just because I hate having to burn up a couple of minutes here in the stream, like getting reacquainted with the code. Let's see. So here's our step processor. Here's our planner. Let's see, where's our exploit prompt? There we go. Step prompt comes back. We bind with tools. Hey, no problem, Dan. I'm trying to remember each of the steps because we actually had a very... Let me see if I can find it. Where is our... Oh, dang it, I knocked the tablet offline. These stupid cables. If I can get it to come back. There it goes. That's over here. All right. Let's take a look here. So this is kind of like, we're having to go several layers deep into the Stinger state. We're working with some very deeply seated data. So we go to the task, we go to the output. Our exploit task is stored in the output. Exploit task has exploit steps. Okay. Probably should go ahead and put some flavor text in here whenever I remember to. About what each of these functions does. It'll help get me back up to speed quickly. Let's see. So our exploit step processor, we go through and we find the information we need. The language prompt we're doing is this one right here, get exploit type. So let's go look at the prompt real quick to remind ourselves. This is step prompt template. Okay, so we tell it, given the exploit task, analyze the output and determine the status of the task. That is not the correct one. That's the status prompt. That's not the step prompt. Here's the step prompt. Let's see. So we tell its job is to gain initial access to the target, analyze the given task, and determine the appropriate tool To complete the task, additional context can be provided. Okay, so this is actually where we're pulling out what is the first step and then analyzing it and then running. All right. Let's make a note of that real quick here. So this will, actually, let me look at something in the state table. Because I think in exploit task, we started tracking the current step. Yep. Let's see. Find the exploit task current step. Let's make a little note here. And let's see, and send the step with data to the LLM to find an appropriate tool. I'll just say to find a tool. There we go. That's what we're doing here. I want to make sure I should be documenting this a little bit better as I go through it. But it looks like it did work because our first step here was the task was create a simple PHP web shell. Output said, yeah, I'll help you create the web shell. I can use the get PHP web shell diceco function, which will return a web shell. Boom. So there's no, you notice how this says none and none? It's because there's no variables. There's no input to this function. It literally, once you make the tool call, it just returns the web shell. So there's all the contents of the web shell right there. Thanks for the suggestion from last night. You mean for like looking at road tools? That's a cool suite there. Dirkjan is just a crazy smart guy. Let's see. Oh, we had an AI message here. A pending tool call output. Okay, that's right. So the step updater takes our step. So if we look at our, where is it? Exploit steps, I think, are up here. Yeah, so we have our output. We take the output from that and go and append it. Okay. And then for our revisor, what are we doing here? I'm trying to remember. So much data here. I wish I could collapse this down more. Oh, there we go. So for, so the supervisor is checking the status of the task. In this case, task 0, step 0. Let's see. So come back, status validated. We probably should come through and actually add something to the response here that says, if it's going to come back as validated, to make this a more concise output, because we don't necessarily need this. I take it back. I do kind of want all this, even though it makes it super verbose. The reason is because if we need to go troubleshoot what the language model is doing and how it is processing, this is where we want it. Hawks of Code. What's up, man? Thanks for coming online. Hack the planet. At least you're not Hawks of Tua, because that would be real bad. So, could not help myself. So joke. Yeah, I know. It's probably like a 3 out of 7. Not even like average. Let's see here. Cool. Well, that came back as validated. So, take a look here. So if that's the case, if that comes back as validated, let's go find that code real quick. Here we go. So for our exploit step revisor, there's, I think, 2 things we want to do in this. Let's see, this should check if the exploit step executed correctly. If not, no, update the step. So basically what should happen here is as we break this exploit task down, and then we break it down into its component steps, the working theory is that we run the steps, we're going to run them through this loop here, right? As they come through this loop, when it hits this analyzer, if it validates, it says, yes, this step completed correctly, it should go proceed to the next step. If it doesn't, what should happen is we would leave the current step where it's at, and then we would make another language model call that says, okay, well, what do we need to do to modify this to account for whatever this error output that came back is. So that's how we're going to try to take a look at this. I don't know if I got that far in the revisor, though. We did not. Okay. So we did it. If it came back validated, yes. If it comes back failed, or if we bail out, this is what we're looking at right here. So we do need to do some modifications. Modify! I was able to reverse engineer how they did it, so I built that into my own tool. My only issue is my Azure account is disabled. Well, if you do internet hood rat stuff, man, they catch up to us occasionally. Actually, I've got something. So I mentioned it on stream where I'm going to make a CTF based off of the last penetration test I just did because it was so weird and so odd. And I'll give you an idea here. The entire theme of the CTF is going to be misdirection. It's going to make it look like you've got like a straight shot path forward, and then every time you try it, it's going to be like, bam! It's just going to knock you down. So it's going to be probably heavy in some AWS and some Active Directory. The two are going to be integrated together. I got to figure out how to even build the stinking lab. But the last test I was on was so weird, I want to build it. Let's see. So let's take a look here. So if this fails, what we want to do... Let me look this up real fast here. So the step processor, actually the exploit step planner, should be where all these steps get created. So what we want to do is we could use, I think, the similar or same template for the step planner, or maybe even the step processor. Actually, I don't think so. We're going to have to make a new prompt for the revision step. So when it comes down here, if it fails, we're going to make a secondary language model call. It's going to say, hey, here, make another call. Here's a new prompt. Here's all the new data. Figure out why this failed and suggest a correction for it. And then probably what we'll do, let me look at something real fast. What we'll do is we're going to check the length of this tool right here. If this tool gets beyond 3. So remember, every time we execute a tool for a task, we append that name of the tool that was executed here. So if this tool list actually tells us how many times we have tried to modify and iterate and course correct on this task, right? Or this step. Gotta keep the term straight. This is the step. So if this tool value gets beyond 3, we'll know, okay, we have hit probably a dead end here, and we cannot get around this. So that might be the bailout condition. So we might check right here that says, hey, by the way, is the length of this greater than 3 now? Then bam, yeah, we bail out. Oh no, account got banned or got disabled because I didn't want to pay $6 for their crappy service. Yeah, dude, let me just put it this way, Dan. It was using AWS services I didn't even know existed. I did not even know it was a thing. I learned about it and was trying to learn everything I could during this assessment. It was such a beatdown. Oh, let's see. Actually, I just thought of something else. So like I said, the entire theme of it's going to be misdirection. So there's only going to be one way to pivot in the environment. It's going to be a multi-computer CTF. And I'm going to purposefully break that method, and you have to figure out how to fix it, because that's exactly what happened to us. Evil Blaise is kicking into full gear with that one. Let's make a little note here. Let's see. Let's say let's do something here. We'll say check if the exploit step tool has 3+ entries. It's greater than or equal to 3 entries. Yeah, we dude, then that's not actually uncommon. Yeah, we had to fix stuff in their environment to make it work, to be able to just pivot through the network. It was really a beatdown. The other big part of it too was and this is a constant challenge that every penetration testing firm has. No matter what they say, they're dirty liars. Occasionally you just have a problem with scoping it out and making sure that you thoroughly understand the client's environment so that you can target things appropriately. And that was one of the rare misses that we had. We do a pretty good job of that, but this is one of the cases where, yeah, we should have done a better series of asking questions. I was not part of that initial scoping, so I can't say exactly what happened, but that was or why it happened, but that was what happened. Was we should have known a little bit more intel ahead of time when we were planning out the attack. Let's see. We'll have this. So if it fails, what I want to do is, so for our error correction, let's go see what we've got going. What do we already have extracted? So we're going to check the status. We're going to see if it's validated. So our status options are, we can do new, working, validated, failed. So if the status is failed, what we'll do then, we'll take all those pieces of data, we'll kind of re-extract them, or we'll just restructure them. We'll send them to the language model. Yes, that's what we're going to do. I need to learn how to make CTS because one of the last penetration tests I had was done in a cool way. Nice, man. They have their own special set of challenges, especially like if you try to prevent let's call them extraneous attack paths, right? You're gonna build it with one attack path kind of in mind for people to wiggle through the network. But invariably what happens is there's new exploits or different ones that you just didn't think about that get introduced into it. So the kicker with this one is going to be I got to figure out how I'm going to tie in the AWS tenant. And so thankfully I have a coworker who is very smart. I'm going to, and I can lean on for that. I've also got my own professional development stuff around Azure and AWS that I need to go work on. And that'll help out with that. Let's see. All right, so if this fails, actually, I think I would leave this. We'll probably only mark this as failed at the very end. We'll leave it as working for now because this step should already be listed as working. So what we'll do here is set exploit step status to failed. So if it actually hits this failed status, that would mean this was the step that we bailed out on this exploit chain. That's what we're doing here. Okay. Let's do it that way. All right, so let's see which values we've got up here. Essentially, we can kind of duplicate this right here. Yeah, so let's actually duplicate this. Because we've already got, this is already using all the basically helper data that we've extracted, so we can just make reuse of this, just like so. And what we'll do is, actually, you know what I think we could do? Oh, 1 second, let me think about this. We actually could make this a slightly bit different. Because what we're doing is when we built the language model, right? We're binding this exploit step status output identifier, right? This is over in our output formatters. So what we could do, where's exploit step status? Here we go. So literally it only returns one field, which is a status. We could actually put that into one. We could work that into one right here. Yes. Because all we have to do then, we could actually do this all in one language call, where basically it says, if it was unsuccessful, then return a revision to the task. Bam. Yes. More efficiency. Love it. I know all about scoping issues because my old job had like this Excel spreadsheet for scoping, and new managers or principals would input things wrong and make things a nightmare. That was actually, so at my my first pen testing shop that I worked at, we took over scoping. We absolutely refused to let any of the salespeople or anybody outside of the penetration testing team do the scoping, because they would way miss it and just absolutely jack up the scoping. So we just said, fine, you're putting us into the sales loop. When you get to this point, we're going to come in and we're going to scope this. And so we would start coming in and asking the questions. We would do the scoping for it. And even then, we still had misses because we're depending on what data comes from the client, what they tell us and how they explain things. But it was a lot better experience, though. Vastly improved. Let's see here. Actually, yeah, I like this. No, we could just make this a string. Just like so. So since this is a pydantic model, what we need to do is we'll need to give this a field with the description. Let's see. So for this one right here, what we're passing this is the task, which is literally just the step task. This is our string, right? So we're going to take as a string back. We'll say this is the revised version. Did I spell revised wrong? Oh yeah, I spelled with a Z. We'll say the revised version of the exploit. Actually, we'll say revised version of the task. Adjusted for previous errors. Previous errors. There we go. Okay, actually, yeah, this will be great if we do it this way. Yeah, we can do that. Nice. Because if it fails, then all we have to do is we can do this one language call, right? We can get this, the status right here. All we do is we get the revision, boom. So one thing we do need to do though is we'll have to update the prompt. So the prompt for this, actually, let's put a little note in here. Leave blank if status is validated. Status is validated. There we go. One manager put a /16, so since it was one IP address, it was the only host. So yeah. Oh my God. So if anybody who doesn't understand what that means, so a /16 IP address means that you have 4 sets of digits in an IP address, right? So just for anybody who is not maybe like up to snuff on networking, no shame. But what happens here is, let's say, for example, you have an IP address of... Don't tell me my pen died. No! Dang it. My pen died. I don't know how it dies. I never used the darn thing. Let the pen charge up. But anyway, what happens here is when you have an IP address... Do this. So let's say like I have 192.168.20.55, right? So each of these sections here is 8 bits, right? So the slash tells you how many bits match before you start entering like the section of assignable IP addresses. So that's 8, there's 16. Basically meaning you've got 2 sections 16 bits worth of addressable data. So that's 2 to the 16, which is like, what is that? 65,535. That's what this is. You got 65,535 combinations that can happen here. So that's how much the effort was scoped at, was at 65,000 IP addresses, when really there was one. So it's bummer because you're taking a lot of extra time from the client you didn't need to. And I totally get that. That's rough. We've had similar situations to that, Dan. I think every penetration test has. Let's see. Let's come over to prompts real quick and let's update this one. Because the prompt we're using is... Wait, where is it? Get exploit step status, yes. So let's go find that. Determine the status of the task. We'll say this. We'll say if the task is validated. Actually, we'll say this: if the task fails, provide a say revised task that corrects for the error encountered, for the encountered error. Potential the error or blockage. Yeah, we'll say that like that. He charged for one IP address. Oh, I had that backwards. He charged for one IP address instead of 65,000. Oh, that's even worse, because then you're on the hook for that. Because you got to think about it this way. Okay, so let's say you do have an error whenever you're scoping out one of these assessments. It works one of two ways. You either overscoped, which is you're charging the client too much. Then when you tell them, hey, by the way, we can actually save you some money because we realized the address space wasn't as large or the effort wasn't as great. Cool, we can back that down. Client's happy, they saved money, things like that. The other thing that happens is you have to go through what's called a change order. And so when you hit a change order, it's because you find something that requires a massive change to the way that assessment's going to be executed. In this case, one IP address versus the actual 65,000, which is a large bump in effort, which usually means a large bump in price. And so those usually aren't fun conversations to have with the client or for the people either. So it usually pays to try and get it right the first time. It's a moving target, though. It's very difficult. Actually, yes, I think this will work perfect. If the task fails, provide a revised task that corrects for the error or blockage. We'll go ahead and put some extra additional instructions in here too. We'll say if the task, what's the value that we used? Succeeded? If the task is validated, there we go. If the task is failed, actually, here we go. We'll put it like this. This will work. We'll say if the task status is validated, I've got so much message here. Let's see. If the task is validated, leave the... dang it, I'm losing my mind here. What was it? What's the other field? Revision. Leave the revision field. Leave the revision field blank. There we go. We did multi-year contracts, so yeah, we did most of the cost eating of it than anything. Oh, dude, yeah. We had one like that with one client, though. They literally had hundreds of thousands of public IP addresses. They were just an absolutely monstrous company, and we had kind of like recurring. It wasn't a multi-year deal, but it was recurring deals where they would constantly come back to us for work. And dude, those were always such a beatdown. It was always a rush to try and get those complete. There was just so much to look at there. All right, let's see here. I think that will work. I kind of want to try this. So we need to actually, I just realized there's an error in the code though we need to address, which is, let's save our prompts here. Save this just in case I accidentally made any mistakes to it. So what we'll need to do is, we actually need to go find the exploit step. Because see how we return the entire task here? So one thing we'll need to do is, in the state table, we need to go find the actual exploit step, or no, sorry, the exploit task here. And we need to increment the current step. We need to, oh wait, I did that. Yay, thanks me. So let's kind of copy this. We can actually take all this back out. Actually, I do want to do AI messages dot append. And what we'll append here is take that back. What I need to do is, I think this AI message. What was the form here? There we go. No, that's not correct. Yeah, AI message. There we go. Why wasn't it giving that back? AI message. Yep. We want to do an AI message, and we'll say actually, I'm going to copy this right here. Let's copy this. Keep it simple. Exploit step revisor. Let's see. Checking status of exploit task. Actually, there was a typo in that I need to fix. Task 0, step 0. Let's see. What we're going to do is we're going to say we're revising this. And let's do this real quick. So from our output formatter, what we'll do is we'll go ahead and extract the revision too. So this will be the exact same thing as this, but instead of getting the status field, we're just going to get the revision. Just like that. Boom. I did a lot of universities every week. Was like a /16. Since I switched to red teaming, I haven't had more than a /24, thankfully. I know, right? I mean, occasionally I'll see a little bit larger ones, which for red teaming is like a /22 network, which is so for a /24 you've got 256 combinations of IP addresses. That's not a lot. It seems like a lot if you've just been doing CTFs and like you're getting new into penetration testing. Trust me, you get used to it and it works out from there. But when you're in a /23, that becomes like 500 IP addresses roughly. When you get to /22, it's like 1,000. But rarely are those 1,000 IP addresses used up. They're leaving themselves room to scale in the future, most likely. Let's see. Actually, I'm going to put this in here. I'm going to put in this revision in here. So we're going to make a little AI note that says, hey, this is what we're doing. And then what we're going to do is we're going to go... I'm going to use this as my base because everything is so deep in the state table. Let's see. So we don't want to change the current step status. What we want to do is change the step task. Like the step task, this is going to now be equal to the revision right here. I think that's it, actually. We just want to update that revision. Let's see. Did we update the tool call, though, actually? Let's see. This is our exploit step revisor. Did we capture the tool output? Oh yes, actually, the tool output I believe we captured in the last call. Did we? No, we didn't. Because before the revisor is the tool node, right? Oh no, we did. We have exploit step update. This is where the little pieces of information. This doesn't make any language model calls. What this does is, in fact, we can look at it real quick. So the step update here. Let's go find it real quick. Wait, come back. Actually, I'll show you down here. This will be the easier way. So let's go to number 5. And then step 0 working. See how we have the tool call was the get web shell basically right here? That's where all that in the output, that's where that stuff gets appended to. That's funny. I didn't realize in the Dicego web shell, he actually had a contact information. That's an IOC right there. I do a metric crap ton more fishing though. So what's funny is I actually haven't had to do a ton of fishing in there. We did the latest one we just did. We used cuttlefish, which was really cool, and a lot of the other guys on my team really like it. I have actually not used it, but it's really cool. It's a browser in the browser, basically man in the middle type setup. So the server sets up a web browser and then basically pipes a video feed of it to the user, so it looks like it's a legit session. And then when they log in, they're logging in on a legitimate browser, right? Not like a PHP phishing page or anything like that, or not like an Evil Jinx landing page. Then we can just dump all the session cookies out, or on the Cuttlefish server, we can just go interact with that web browser that's now logged in as the user. It's really sick. Yeah, the one from Forrest Kessler. Yeah. Really, really cool tool. He was a hiring manager? No, I didn't know that. I don't get to talk to Forrest a ton, so I'm not surprised I didn't know that, but that's interesting. It's always funny just like learning little bits about everyone's background. All right, let's see. So the step revisor should already have all that info in there. Actually, probably... I want to take this out. I want to do actually a sanity check here at the beginning that basically checks at the very beginning of the revisor here. The revisor, what we should do is actually we should go check before we even make the language model call. If the tool list length is 3 or more, then bail out. We've already tried 3 revisions on this. We want to get out of there. Yeah, the few times I've gotten to talk to him, he is a really cool guy, Dan. Let's see here. What else do we want to do with this? Okay, so let's go ahead and add this in. Let's see. Check if the exploit step executed correctly. If validated, set up to move on to next step. Let's see. If failed, update step with revision. Let's see. I didn't spell update correctly. First thing we're going to do is we're going to check, see if... Let's see, if step... Let's say if step tool array length is greater than or equal to 3, then Marcus failed and bail. There we go. You got to try Cuttlefish when you first made it. See, I didn't get into... I guess I hadn't really heard of Cuttlefish, and so instead I had been working with Evil Jinx, which Evil Jinx is a really cool idea, and I really like the idea, and Kuba is just a super smart guy as well. I've enjoyed it every time I've gotten to chat with him. Hopefully one day I'll get to meet him in person. Dude, I gotta tell you a funny story. Um, so the week my dad passed away, I was actually in Chicago because we had a big company meeting, and I was up there and I was looking forward to finally meeting a buddy of mine who I have talked to and known to and shared lots of life events with, and he worked with me at my last company, and then basically got me hired at my current company. And but I've never got to meet him. He lived in a different state, and we've always just talked on the phone. We've talked on Slack and other things. And I was finally going to get to meet him, and I was like, "This is great." So his flight got delayed. He didn't get in till like 1 a.m. So I didn't see him the first day. The next day, I got to see him. They had a big company breakfast. I saw him for all of 5 seconds, and I was like, "Yeah, man, I'll catch up with you at the first break." No kidding. That's when my brother called, and that's when I immediately booked to the airport to get the first flight back to Dallas. So I was like, "Dang it, man!" I was like, I told him, occasionally one day we'll get to go hang out, but just I was so sad not to get to spend any more time with him. I literally saw him. We did the bro hug. I was like, "Hey, man, good to see you. Yes, I'm gonna catch up with you soon." And then that was it. That was the only time I've gotten to see the dude. Well, he's a really smart guy too. So I'm surrounded by smartness, and it just makes me feel dumb. Let's see. So that's our revision, and then yeah, that's it. That's what we want to do. I believe that's it. And literally, we're going to use the exact same return value here. I'm going to take out this extraneous note here. Don't need that. We know what we're updating here. But we do want to come up here and let's do our first sanity check after we extract our helper values. So once we find our exploit step here, let's see, we're going to stay here. We're going to check for step failure. And so what we're going to do is we're going to come check this exploit step. So we'll say if so what we're going to do is for the exploit step, we're going to check the tool value here. And all we're going to do is we're just going to check the length of it here. So if the length of this is greater than or equal to 3, then what we'll do is we're going to update the state table. We're going to mark it. So, actually, we can actually come down here and do this. Copy this right here. And then the failure is going to be handled whenever we actually pass it back up. So here, I'm going to change this to failed. So this step fails. At this point, if we can't get the steps to work, then we're going to bail out of this exploit chain. So what's going to happen? That's part of becoming a penetration tester, was meeting all the people and how many come from different backgrounds. And no, it is kind of weird, the absolute huge array of diversity that you meet in offensive security. It's kind of weird. And like, think about just like my own case, right? Yeah, I've been messing with computers since the 2nd grade, but prior to going into IT as a career, let's see, what did I do? I worked at Home Depot. I taught martial arts. I worked as a security guard. I sold cars. And it's like, so I had a little bit of a weird array of background before I even went into that field. I don't know why it line wrapped that. Probably because the line is too long. Let's see. So what we'll do is we're going to say this one, step 0, failed. And we'll say failing out on exploit task. There we go. Hey, Cypher, what's up, dude? Happy Saturday. And in fact, down here at the return here, we can actually just have our return value come back. Because what we're doing is we're updating the state table directly, so we can just basically emit the task to what we're going to update in our messages.
Shut up, baby. I know it.
Let's see. Let's see. We'll say has failed. There we go. Failing out on the exploit task. And then all we have to do now is just actually use the exact same return here. I mean, really, there's not much point to having these individual returns. I'm going to leave it like this in case I need to update it later. I'd like it to be explicit where we're returning from. So yeah, could we go through and make this to where it jumps over everything else and wrap this in a giant else condition? Yes, we could. Or I can just put a return statement here and know exactly what is happening right now. I'm going to leave it like that because it makes the code much cleaner and more readable. Went from law enforcement to penetration testing and never been in IT before. Oh, dude, but I mean, if you have like an investigative mind and you're looking at things. So, for example, one of my favorite shows to watch on YouTube is the Y-Files. I absolutely love that channel, and I've been a big fan of it since before, when he was a tiny channel. Like, I think the channel was like a year old when I discovered it. And it's funny, though, because like he'll talk about certain things, particularly around like the physics of certain objects, and I'll be like, oh, that's where they messed up. And it's always fun to go, like, when he goes through the debunking section at the end. If you never watched the Y-Files, go check it out. It's up on YouTube. It's WHY Files. And the episodes are just phenomenal. And AJ does such a good job of presenting that stuff. What happens is he presents it as if, like, this is the actual story, and he doesn't provide any judgment or context outside the, let's call it the unofficially official story behind whatever the conspiracy or paranormal activity is. And then he goes through and he has a debunking section at the end where he's like, yeah, here's where this gets weird, and here's where this doesn't quite make sense, or here's actually this is the weird part that we can't explain, and it really was like that. Go check out the Hollow Moon one. That one's cool. But as he goes through those, it's fun because it's like a game for me and my wife, because she worked in law enforcement. I just have a strong logical background, math and physics, right? And so it's kind of fun game for us to go look at. Hey, where can we spot the errors in this? I'm just a chimpanzee. I break things. You're more than a chimpanzee, Cypher. I'd say you're more of a gorilla. You just smash. I take one of you over 100 of any other guys. Let's see. Actually, I think that'll work. I'm not pooping. I'm literally on stream, Cypher. Dude, don't abuse the poop privileges. Wait, that sounded terrible. No. No. Although I knew you were going to do that, Cypher, I thought about putting like a flush soundboard, like just a toilet flushing sound. I should have done that. Just for that, because I knew you were going to pull something like that. I knew, and I knew specifically it was going to be you. I think this is actually good right now. So we update the step, we validate it or we reject it, we send it back around. Let me go take a look at one more thing. Let's look at the beginning of the chain here. So after planet, we're going to go to the step processor. So let's actually go look at the step processor real quick. So in the step processor, we're not modifying anything. What do we emit out of this? We return messages and tasks. Okay. This could be solved with some simple code and a PLC with a pressure sensor. I don't know what pressure you're wanting to measure, sir, but no man takes that route with me. Reminds me of, damn, showing my age here again. Hilarious old movie back when you could still do slapstick comedy, right? Which was Hot Shots. And I think it was actually Hot Shots Part 2. And one of the pilots, he's like losing his vision. And one of the ways they wanted to go in and correct his vision without hurting his eyes was actually through his rectum. He's like, no man's taking that route with me. Oh, on the chair. Okay, that's a much cleaner way than I was afraid you were going to suggest. I think this is actually solid. Actually, there's one more change we need to do. I think, really, after the revisor is up. So in this case, we update the status to validated. Let me check one thing over in the trace real quick. Let's see. So the status is still working. So we leave the status alone. I'm going to put a note in here. Leave status as working. Actually, yeah, I think that works. Nice. Yep. So now all we really need to do is not close it. That was smart of you. What we need to do now is we just need to wire this into our loop. The revisor just needs to be wired back up to the step processor. Actually, I take that back. We need a step router in here. What are you doing, step router? Oh, that sounds just absolutely horrendous, and I have no idea why I said that. But we do need a router here. I'm an innocent angel. So you guys know I turned on the swear jar on the stream. I don't know, maybe a month ago, 2 months ago, and it's not very high right now, right? We're talking the swear jar is not super high. Well, hang on. I'm going to tell this story here in just a minute after the ads finish for everybody. But what we need to do now is we need one more router. We need a router that says, hey, do we send it here or do we send it back up to the agent? I think that's what we need to do here. So let's go build that out real fast here. So what we're going to do is we're going to define what's our router called? Exploit router? Yeah, we're just going to call this exploit step router. And this will take in the same thing here. It should just take in a state table as a stinger state, just like so. And actually, I need to go remember how I want to check this. Let me make sure I remember how I did this. In this case, we're working off the last message, which is not what we're going to do in this case, but I'm copying this code down here and I'm going to just modify it as we go through. So we'll get the current task. Let's take this out. We don't need that. We do not need the pre-flight check. We do want to get the current task. And what we'll do here is we'll get... So from our current task, we have our... Oh, how did we find the current exploit task? I don't remember how I had done. This is how we did it right here. We'll just have to run through this again. It would make more sense if I kept that over in the state table than having to come through and do that, but it's fine. Yeah, we can take this out. All right, so here's our AI messages. Actually, AI messages we don't even need because this is not going to emit anything. Let's see, so our current task and then our task, our current exploit step, we get this. All right, so what we want to do is, actually there's one more piece of code I need up here. I don't feel like rewriting it. I need this part right here. There we go. All this is, essentially you can almost think of it like boilerplate we already put together for just extracting some helpful. I still don't know why it does this. Expected an exploit step, got an exploit step. It's like whatever. All right, so since the ads are done now, yeah. So you guys know about, I don't know. It was several weeks ago. I turned on the swear jar. I've actually been working on trying to clean up my language, and not doing my best impersonation of a Navy sailor, right? Well, I said every time it hits like an increment of 50, I'll go make a donation for $50 to St. Jude's, right? And we haven't hit that yet. I had to call the bank about some of my dad's accounts because they had so royally screwed up something. I would have, if the stream had been on, I would have blown that value straight out. We'd have been talking probably 3 or 4 donations. I was livid this morning. And I was telling my mom about that as I was explaining to her what I was trying to basically get fixed. Almost did it again. And that's like, I told her about the swear jar. I was like, Mom, that thing would have been overflowing if I had been keeping track. Let's look at something. So, what we're going to do is we're going to do a status here. So we're going to say status. Let's get that from our exploit step, and our exploit step, that is the status right here. Actually, we don't even need to extract that. I tell you that. We'll reference that directly right here. So okay, so we do have our exploit task index. Yep. Okay, cool. My mom's also been handling her parents' estate, capital S stressful. And it shouldn't be this stressful also, especially, it probably wouldn't have made me so mad if I had not been on the call. I've been calling them to like handle things, sort shit out. See, I just did it. I've been doing that for the last 2 weeks, making calls pretty much like every other day for the last 2 weeks. And I was just, the frustration finally got to me with like how many times, like every time I call them, I get a tiny new piece of information. Eventually, I'm just going to start calling them on a regular schedule and just be like, hey, what's my new nugget of knowledge for today, guys? There's a timeout on the swear jar cipher. Let's see here. All right, so now what we do is we just need to do an if statement here. So what we'll do is wait, did I have this all kinds of messed up in here? Let me see. There isn't an ACL. I don't know if I did it where only I can do it, actually, Cypher. I don't remember. We'll find out. Let me see. So we get the current task from the state table. We find the current working task. We set the exploit task index to 1. Our exploit task is going to be... Oh, that's not right. This is totally not right. I need to go double check something in the code because we can't reference the exploit task index if we haven't used it yet. Hold on. Don't tell me I screwed that up here. Oh, no, I didn't. I just copied and pasted it in a weird way. Yes. So we run through the for loop to find the current working exploit task. Okay, perfect. So then what we'll do is, now that we know what that is, what we're going to check is... all we're going to do is we're going to emit the name of the... or not emit, we're going to return whatever the string name is of the node that we're going to jump to. So what we're going to do here is go ahead and take this out. So we'll say if yeah, that's what we'll do. We'll say if the exploit step status equals to failed. Then we're going to return. All right, I'll just throw this all in one line. We're going to return actually, I take that back because let me think about this. What's going to happen is the step processor should also have logic to say that the task failed. So probably in the revisor here, in the revisor, actually, we may need to mark the entire exploit task as failed. See that? Let me bring this over. This needs an additional value here. I want to call this skipped or failed. I'm going to change this actually. We're going to change this to failed in here. Because what we're going to do is if the exploit step status returns, if this is failed, and actually we want to do this up here as well. Correction, actually not here. We want to do this at the first check. Check for step failure. Yeah, there we go. Because what we'll do now is instead of marking the step as failed, the exploit task status itself is going to be marked as failed. Let's make sure this is going correctly. So from the task indexed on the current task, yep, our output, we get the index and we set that status to failed. Yes, so this should be the exploit task right here. Yes, that should work. Let's see, check for failure. Yeah, okay. So basically, we're going to give it 3 tries for each step. If the step takes more than 3 tries, then we're going to mark the entire exploit task as failed. We're going to move on to something else. And that value will probably have to be adjusted later on, but that's fine. So here in the router, what we'll say is so if that has failed, yeah, basically what we're going to do is no matter what, actually, let me see here. I got to think about how we're going to exit this loop. So these right here should be making a loop. What I'm doing right now is I'm defining the routing here. So let me move this out of the way. So what's going to happen is we need one path that says, hey, go back to the step processor to begin executing the next step in the exploit chain. We also need one that says, hey, we have failed, but that can be the exact same path up here. If it's actually, so if it's failed or validated, we can send it back up here. Probably, oh, let me think. There's another check we could do in the step revisor. When we find out the task validated, we can check out if it's the last task in here. Oh no, we're gonna actually have to have this call out to the validator, which is a pain because how am I going to do this? Basically, I want to be able to send it to the validator and to validate that the payload actually worked. And if it did, then go back. If it did not work, then go back over to the process.
Bullshit, I can't hear you. Sound off like you got a pair.
Frozen. Keep your trust issues, bro. Just want you to know that. What's up, dude? Happy Saturday. Let me think about this. So, because eventually what's going to happen is when we reach the end of the loop, right? Let's say we get through all of this, we hit the validator. What we could do is we could add one more. We could add one more node right in here. That's basically. This really should go to the exploit validator. I'll work on that in a minute. I think for now, what I want to do is we're going to say if okay, so in the router here, coming off of this guy, pretty much no matter what, it's going to come back up to the step processor, unless there's certain conditions met. So we'll have those conditions execute first, and then the default condition will be send it back to the step processor here. Yeah, I think that will be the most appropriate way to do it. Yeah, so what are the conditions whenever we want to bail out on this? If we complete all of the tasks, so if every step of the exploit chain was completed, and let's take a look at that. So like, what's the last one here? We have so many steps in here. This is gonna get so deep. Let's see. Because I've basically just been focused on this one task so much. I need to think through the rest of the chain here as it goes through. Like, for example, some of these are things we're not going to want, like try bypassing file upload restrictions. This actually should be handled in the base execution. Let's see. Is that something we could handle in the step processor? Oh, I don't want to do this. Let me think about this. I told y'all this was going to be the hardest one to work with. I'm pretty sure the post-exploitation LangGraph part is going to be simple. It's simpler, right? Actually setting it up to interact with Mythic is going to be the harder problem there. And actually, I have a project that I'm planning on using as kind of like the template for that, and it's called Sage. So this was one that fellow wrote. Let's see, where's Sage? So actually, this is an AI interface to language model callbacks. So I thought we would actually set this up, we'd wire it up and kind of test it out a little bit, and then figure out how it's functioning. I'll probably get Cody, it's a feature, back on the stream. So if y'all have questions about Mythic and stuff that y'all want to talk about, we can. But have him walk us through like, okay, cool, what would be the best way to approach this? I'm thinking of essentially using Sage as the template and then modifying it, reconditioning it, and then building out our own, basically like agent that would be integrated into Mythic that could then issue commands to other agents. Basically kind of like a meta agent. That's my current thinking on the subject. But anyway, first bridge to burn is how we're going to handle this. So if it fails, if the step fails, actually I take this back. If the exploit step status is set to failed, yeah, we're still going to send it back to the step processor. So we don't need this. What are the conditions where we actually need to send it out of this? The condition would be that we get a successfully working exploit. If through all this execution, right, we come through this loop right here, right? In fact, hold on, I'm gonna hardwire this real fast so we can just visualize it. So let's do exploit workflow. Let's add an edge here. I'm gonna make this a hard edge, and this is gonna go from exploit step 3 Visor. And it's going to end at exploit step processor. Right here. Let's see. I'm going to call this placeholder edge. So now if we can look at it up here, did I get any errors? No. Oh, how come it didn't redraw the graph for some reason? Load this up. Everything's running. You gonna work for me? Usually when it gets to spinning like this, it means the port for the SSH tunnel died, but our SSH connection is still up. Well, let's do something. Let's go ahead and kill this. This server has been running for a very, very long time. It looks like the server probably hosed up. While I'm at this, let me double check these. Good. Why you no die? Oh, what the heck is going on? We'll just kill the process. $89 bugs on the wall, take one down, patch it around, 100 bugs on the wall. That is how it works. This is so weird. I wonder why it... Well, I asked nicely the first time. Alright, let's give it a second here. Address already in use. What? Dang it. There's a dangling socket on the server. Piece of crap. What port is it listed on? 2024. For some reason that one is actually doing it. But that's fine. What we'll do is we'll just kill that one too. Kill it. Kill it with prejudice. Now we're talking. Alright, let's see if the server will come back up now. There we go. Socket wouldn't be dangling if you just went to the bathroom like an adult. Get wrecked, son. That's not my socket, that's my ratchet. What's up here? And don't tell me that by making the loop, I broke it. Oh wait, you know what? Actually, I think the problem is, come to think of it, I think it might be this exploit step router. No, because we're not even. That's there, but it's not actually piped into the graph yet. That shouldn't be breaking anything. I don't think it likes the hard loop in here. Dang it. Okay. Let's just do this then. What we're going to do is we're literally just going to return. Not that. We're going to return exploit step processor. Let me try that, and then we'll go ahead and just... So basically, this router's not doing anything. But we can go ahead and add it as a conditional edge. So what we'll do is we'll take this out. We'll add in our new conditional edge. Let's see. So this is going to be sourced from exploit step revisor. And this is going to be our exploit step router. Then the path of execution here. This will be our exploit step processor. And then the other one we'll say exploit agent. And you know what? I am going to do something. It's going to look funny, but essentially what I'm doing is I'm just forcing the execution here. This will look really funny. If exploit task index, then return the exploit step processor, else return exploit agent. There we go. So this is going to look kind of funny. But we'll see if it actually works here. There's something in here it really doesn't like. Because for some reason, what should happen is this server should go through and hot load. And for some reason it's not. And I don't know why. Probably because the server's been on for too dang long. Yeah, it's been on for like 49 days. It hasn't actually been on for 49 days because I'll go through and I will suspend this server when I need to shut down the physical hardware because this is a virtual server, but still. How many control C's until it dies? You know what I ought to do? Come to think of it. I just copied it. See what happens. Like, yeah, terminate you. Why not? Let's just do a little bit of bin bashy here. Bin SH maybe? This might work. Uptime cheater. Only a little bit. There we go. See if this will actually run now. Hey, there we go. Now we're talking. Hey, Caleb. Caleb #1. Thank you for coming online. Oh, I need to drink some more water. My throat's drying out. Welcome in. Happy Saturday. All right. Now let's see if it will actually connect. There we go. For some reason now it has stopped spazzing out on us. All right. So let's go to the exploit graph real quick. It don't like that. Why don't it like that? It likes enum. It likes recon. It's the agent, though. I don't know why agent is just in here. But for some reason... Oh, there we go. Yeah, we're talking. Now we're cooking with propane. All right. Cool. So here's our execution loop, right? Nice. Nice. There actually probably, like I said, there probably actually needs to be one more node right here. It's basically going to be like, because we do have the validator here, right? The validator right now is very simplistic. It just looks to see, does the target host have an initial access exploit? Remember, the initial access exploit for the purposes of this code is an exploit or a piece of code that we can run to get remote code execution, one command to execute on the machine, one or more commands, right? That's all the validator is looking for currently. Probably what we should actually do is go to the validator, and then from validator, there probably needs to be a validator router that says, hey, here's where you can go from here. So if this step revisor, once we go through and kind of massage it a bit, that says, hey, by the way, we actually have that initial access exploit, we can come over to the exploit validator, validate that that does work, and it'll probably have like an example command of like, who am I, that it's going to run, and just to check and make sure that execution does work. And then if that fails, in this case, look how it auto hard returns to the agent. That's not exactly what we want to do. Think about this. I kind of want to just let it run in this current state and just see how far it gets. Let me make sure the system's still up. Let me add one more power onto this. Because the next hardest part it's going to have to deal with is here. Attempt to direct upload a PHP file to the server. We'll probably need to go through also and massage the prompts in here. Basically, because it shouldn't, there's a lot of like, hey, try this, try that, if we need it. But we don't. So in this case, these are the last two steps. So really, all we should in theory need is like step 0, which is to get the web shell. Step 1 is basically upload it. Actually, 1 is look to see are there any upload restrictions. 2 is actually go ahead and upload the file, figure out how to upload it to it. And then 3, 4, 5, 6, and 7 aren't actually needed. So part of that correction loop is going to say, hey, by the way, we didn't need this. Let's skip it, skip it, skip it, skip it, and then come through with it. I probably should actually go ahead and put that in here. Exploit step, new working, validated. This should actually need a skip in here. Because we can then tell if we skipped a step. But I actually just want to try running this real quick. I want to see what happens. Run. Let's see what happens here. And probably this exploit step planner, we could tell it don't worry about mitigations or anything like that. We could then have it come through and do its own thing. Wait, why are we back at the exploit agent? Oh, yeah. We're stuck in a spiral here. Cancel. I know what happened here, because what happened is the router didn't actually route it the way I wanted it to. Where's the router? Here we go. That's the step revisor. Where's the step router? Here we go. If true. There we go. I know it's not reachable. I don't care. I just need it to look like it's reachable. Okay, run it again. So even though we have these theoretical edges, there's no way to actually execute them. It can't get there in the current way. All right, so let's see here. So for generating our exploit steps, it's using a Python execute. And it's happening real fast, so I'm wondering if it's dying. I bet that error we just hit is a recursion error. Let's go look at the trace of it. Oh no, we hit an index out of range error, which is fine. Actually, that means it went through what we needed it to. So let's take a look at what happened here. Well, that doesn't look good. Let's look at the step planner here real fast. So create a basic PHP web shell file named with contents. Access the upload form. Upload the. For some reason, it wants us to upload a JPEG. Let's see. And then it's got a whole bunch of conditions. I think let's go ahead and do, before we get too much further into this, let's go modify this real quick. I do want to see what it's doing, but before I forget, when we do these steps to exploit this, I don't want it to worry about mitigations. So we're going to build that over into prompts. So here's our exploit step prompt template. Bring this over. Just like so. All right, let's see. Analyze the given task to determine the appropriate tool to complete the task. Additional context may be provided. Let's see. Do not speculate on potential countermeasures or bypasses. Provide a concise list of steps as if the system had no security features. Yeah, actually, I think that might work. Let's talk about, oh, well, what if you can't do it this way? Upload as a JPEG, try adjusting the MIME type, do this, do that. I don't want it to do any of that. That should be part of the error correction loop. It should say, oh, by the way, we can't upload a .php file. Okay, well, how do we get around this? How do we work around it? Okay, now we can try uploading it as a .php5, which is the actual exploit it should do. All right, let's try running this again. What did it do with Python exec? I'm curious here. Let's see. Let's also add in another let's add in some restrictions. Let's see. Conditions for creating steps. Let's do this. Do not speculate on potential countermeasures. Let's kind of bullet point this out for the language model. There we go. What we're going to do is have this. What is going on here? trying to just get these to all line up. The formatting is bugging me. And apparently I cannot spell countermeasures. Or bypasses. There we go. Provide a concise list of the steps. Steps as if the system had no security feature. No additional security features. And then what else do we want it to do? We want it to let's see. Actually, we'll tell it this. We'll tell it to Blaise has to prefer provided tooling before creating ad hoc solutions. There we go. We'll try that. We'll see how it works. So we'll add a couple more restrictions in here. I'm a big fan of starting off with minimalistic prompts and then expanding them if you it. Okay, cool. So we can hit the step planner. Wish there was a way to pause this instead of just canceling it. Like, hey, but, well, actually, I could. I could have said, hey, when you enter the step preprocessor break on here, exploit step processor before. Actually, no, correction. That was not the exploit step processor. We wanted the, we wanted the exploit step processor. Break before it enters. Let's go look at the trace real quick. So what kind of exploit options did it give us here? So steps, navigate to the upload panel, create a simple PHP web shell named shell.php with this content. Attempt to upload shell.php directly to the form. If this fails, okay. So it does navigate to it, but then it does a Python exec to create the file. So it's still doing what we didn't want it to. Let's actually go check something. So in the step planner, oh, it didn't. Dang it, I didn't save the prompt, did I? Because for some reason the get exploit step prompt template did not. Notice this right here. This is why the traces are so awesome for figuring this out. It doesn't have our additional conditions that we put onto it. See that? There should have been additional conditions, but on the language model, right here. Don't speculate, don't provide on security measures, make the list concise, phrase task to prefer provided tooling. It didn't do any of that. Weak sauce. Let's go. It should be saved and we should be able to run it again. And then put a breakpoint here on this exploit step processor. So as it enters each iteration of the loop, we can interrupt it. We can go see what it's doing. So even when we enter the loop, it's going to hit it the first time, but that's fine. Actually, this will be great because I want to go see what the planner is going to do first before I continue the execution. Why are the... This is weird. For some reason, the prompt is not populating after we update this. Let's go look at something real quick. Where's our step plan? Validator, router, planner. Here we go. Oh, because that is not the... Am I completely confused? So let's look at what we had from the exploit planner. Yeah, it's using... Did I... It's because I put this on the wrong prompt. That's what happened. I'm a dummy. Let's go clean this up. Yeah, because this is actually for something different. There we go. We actually need to update the prompt before it. Here. The exploit planner prompt. That's why we're getting the same results, because I didn't update the correct prompt. Smooth brain. Let's hit that again. New thread. Run. So it's going to plan out all of our steps here. We should see that now. We should see the correct prompt, and we'll get a breakpoint once it hits the step processor. And let's go take a look at something. There's all of our conditions. All right. It's still doing the create a basic PHP web shell here. And it's still offering solutions for bypasses. See that? Do not speculate of potential countermeasures or bypasses. Provide a concise list of steps as if the system had no additional security features. Phrase task to prefer provided tooling before creating ad hoc solutions, which it's completely just ignoring that because we do have those conditions up here now. See that? But at the same thing, it says, hey, create a basic PHP web shell. Let's try this again then. Let's see. Let's come right here. We'll say, responses should provide a list of steps and reasons for each step. Conditions for creating steps. Do not speculate on countermeasures. Bypasses. What else we want to tell it here? that was not what I wanted. I'm trying to move that particular line up. Okay. So when a phrase task revert to default to provided tooling before creating ad hoc solutions. Actually, I'm going to say before crafting tools. Do not speculate on countermeasures or bypasses. Provide the minimal list of steps to accomplish the task. Provide a concise list of steps. Actually, we can change this. We can say assume the system. If other than system, we'll say assume the target. Has no additional security features. There we go. Let's try that. We're doing a little bit of prompt smithing here. Because really, let's think about what are the bare minimum steps we need to exploit this. We need to get a web shell. We need to upload it. Then we need to call the web shell from the directory. That's pretty much it. You can add in a couple of extras in there, like verify the upload exists, verify that the web shell exists in the uploads directory, things like that. Actually, let's take a look at something real quick. What was the task we sent? So really, where did this task come from? PHP file upload bypass. Maybe that's why. Maybe that's why it's doing it. See that? So the task that it's pulling was from task 5. Let's go find task 5 real quick. Oh, that is not correct. So the task was actually get a remote code execution from a web shell. For some reason, this task right here got uploaded. Let's look at the messages. Let's start down here and kind of work backwards. So exploit agent reworking. So did we get, I gotta remember actually, dang it, I should have added additional. So exploit agent is the one actually getting the list of these here. Yeah, that's what's happening. So there's actually a prompt call over in exploit agent that we need to go modify. So this one is, for the exploit planner is kind of working, but we actually also need to come back up to the agent. Where's our prompt here? The exploit suggestion template. That's the one we need. So we've got another template we need to go massaging. So let's go find that real quick. Here we go. And really, I think rather than having it suggest 3, I just want it to suggest 1. so we'll take this out. Suggest one exploit that can be viable to get remote code execution on the target. Because then what we'll do, that actually makes a lot more sense. So let's take a look at this. If we look at the execution path here, right, exploit step revisor eventually will send it back over to it. So what we can do is on the step revisor, we could have two branches coming off this one. One that says, hey, we don't know what to do now because we've exhausted all the steps in the exploit task. We can then now send it back up to the agent. Agent can look at it and says, okay, let's get a different suggestion. Here's the one we already tried. We make a different language call. Boom. Then we go through this iteration again. We can put a check over an exploit agent that says, hey, by the way, we have tried to exploit this 4 times, 5 times, however many times. We're going to bail on it. We can't figure out how to get an exploit on the system. And that automatically puts the exploit validator over in here. Okay, so we can shift more of the logic back up to the exploit agent. That's what we can do. Nice. I like this. All right, let's go massage this prompt a little bit here. Responses should be in the form. Let's make another thing. Let's see. Suggestions. Can't spell suggestions out. Suggestions should be concise and I don't want to say this. Because what it gave, because here's the issue. What it gave us back was something like a file upload bypass, right? Well, we haven't even validated that there is something to bypass. To be concise and not speculate as to security countermeasures. And so what we can do is we can actually give it an example. So I'll say, let's see. For example, suggest, what would we say? I want to keep this generic. Let's see. How do I want to call this? Tell this. We want to tell it. Let's see. Example would be like upload I'm trying to think what would be a good example here. Hey Dan, are you still on? Or Cypher, one of you two. Or Frozen. Since all of y'all have kind of been through this cycle before. What's a more generic way to say this? We don't want it to say, hey, go, because the task we gave it here, right? Here's the output. Here's task bar. get remote code execution from a web shell. So I would try to give it an example that's not like so poignant as, hey, here's a good example, here's a bad example. We'll give it a list of examples here. That's what the ads are about to run. Guys, go grab a stretch and a break real quick. Get some water. I'm going to do a long ad break, so we're done with ads for the rest of the stream. I'm going to go run to the bathroom, so I'll be right back. All right, I'm back. I'm back. Guess who's back? Back again. Cypher missed his opportunity to hit the poop button. Let's see. All right, let's finish kind of wordsmithing the prompt here a bit. So, upload web shell. Let's see. Yes, exec to remote host with credentials. Say with password hash. And I'm going to give one more example here. Let's say, what's another good exploit? Exploit CVE. Yeah. Okay. Let's see if that will get us a little bit more precise understanding of where all this is coming from. Back to the lab again. Alright, hit the breakpoint. Let's go check. Let's see. So analyze the target information to suggest a viable exploit. Actually, yeah, that actually looks like it's pretty good right there. So let's go at the exploit step planner. So the steps we're telling it to plan is upload a PHP web shell through the upload form in panel directory, then access the uploads directory to gain remote code execution. Perfect. So what steps does it suggest? Create a PHP web shell file named shell.php with the following stuff, yada, yada, yada. Okay. Navigate to the target's upload form here. Upload the shell, access it. Test the web shell by appending a command parameter. Confirm remote code execution by checking if the ID command output is displayed. Oh, I like how it's perfect. It actually has a confirmatory test in here. Nice. All right, cool. Let's let it. So let's go back. Lose my spot. Here we go. Let's let it continue on. I think I gotta go all the way to the bottom till it continue. Oh no, scroll back. So this mouse has like a inertial scroll wheel where like it can do like infinite down scroll. I think I abused it too much though. And so it doesn't like to stick back. It's kind of funny. Let's see. Looks like it was doing good. I think here it should update. Or do we get a new trace whenever we do? Oh, we must have gotten a new trace. So, we'll scroll to the bottom. Ooh, I don't like the way it does that. So, here's what happened. Right, we can tell it to continue, but every time it does that, it almost breaks it out into a new trace. Not a fan of that. Anyway, let's see what we had here. So it did use the get PHP web shell diceco. Perfect. So basically what you see it like we're passing in all of our tools that we've built over in RoboTools. So we get that, and then let's see, advisor. Oh, so it marks this as a failed here. See that? So it came through and it said that that one failed. But it didn't. And so the problem is, again, it's saying we're going to be creating it. So let's put another restriction in here into the prompt. Let's put one more in here. What we're going to do is we're going to say, let's see. Oh, I don't think we put the phrasing in here. What we did before. Let's see. Phrase task to. Actually, hold on. This is incorrect. This is not what we're. Because where this came from here wasn't from the step processor. This was from our previous one. It was from the step planner. Right? So our step planner said create a basic PHP web shell. So let's go look at our step planner here. Make sure I edit the correct prompt this time. So I want to refactor this. I'm going to call this exploit. Oh, I'm not. Because basically all the ones that are in basic, let's look at this like an index. All these ones that say exploit step, right? I actually called it exploit step planner. Okay, fine. Screw it. I'm gonna refactor this. Let's see. Oh, come on. Exploit step planner. Yeah. There we go. Exploit step planner. And this one is going to use Hello Peaches. So the get exploit planner prompt. Let's go look at that one real quick. Phrase task to default to provided tooling before crafting. Let's go give it an example here. We'll say, let's see. Do not say create. Use obtain instead. There we go. What was good timing, Dan? I was trying to think about like what you were. Are you talking about the execution loop? Let's start this from scratch here. Did we hot load everything? Yeah, it looks like it did. From the beginning. Let's go see what happens. Let's go look at this trace. So what did the agent come back with? So the task it came back with is very similar. Upload a PHP web shell, which is perfect. Steps. It did it again though. Hold on. What was did our prompt actually include our new? It had the instruction right there. Do not create. Obtain instead. Yep. Let's see. Let's actually make this a little... So what we're doing is we're doing a negative to a positive. I'm not sure why, but it feels like the language models work better when you give them a positive before a negative. So, use words like obtain instead of create. And then what else could we tell it here? I'm trying to think if there's anything else we could tell it to say, hey, kind of phrase these in a way that you would understand them. Because we don't need to... actually, we could actually, you know what we could do? We could say provide conditions to provide conditional statements to check if a item is available before creating a new. Because if the statement just said, hey, check if we have a web shell available, if not, create one, that would have been fine. Actually, I'm surprised at the lack of prompting, like prompt engineering we've had to do. This is like some of the most intense that we've had to do, and it's even not very crazy. I've been trying to keep the prompts pretty minimal as we go through this. New thread, run it. Oh, no, I didn't mean to hit continue. So the task we told it was upload a PHP web shell by the upload form in the directory. So what are our steps here? It said use the word create. It did it again. Why do you do this to me? Use words like obtain instead of create. Really, I think we could just take this part out and tell it to provide a conditional statement to check if an item is available. Let's take that out. Let's do that. Provide conditional statements to check if an item it's working. Let's see. Do not speculate on countermeasures or bypasses. Assume the target has no additional security features. Provide conditional statements to check if an item is available before creating a new one. Let's try something here. Actually, you know, that might be a good point. Conditions for drafting steps. Or planning steps. Let's try that. Because you're right, it could be conflicting there. Let's see. To check if... And then let's give it an example here. So what we'll do is we'll tell it... let's see. Like, I'm going to give it an example here. We're going to tell it like, obtain a C2. So Dan, this says provide conditional statements to check if an item is available before creating a new one. And you're saying that's conflicting with something? Let's see. The primary job is to analyze the task. Instead of creating a new one, I would try something other than new. I'm gonna give it a solid example here. Like, example: obtain a PHP. Let's see. Obtain a PHP web shell. Full contact programming. Hey, Chris, what's up, brother? Let's see. I'm gonna give an example. Like, example: obtain a PHP web shell. I'm trying to think what would be the phrasing for it. Basically, I want to say, if you've got a PHP web shell, get it. Otherwise, make it. Obtain a PHP web shell. If one is not available, great. And so one of the issues that we came up with here is what it did is it used the Python exec. It used the Python exec command to create the web shell by basically doing a file create. Yeah, sounds cool, except that runs in a Docker container. Yeah, it creates the file, but then it gets blown away because the Docker container is immediately destroyed upon completion. I'm about to throw this keyboard in the trash. I'm actually surprised because as much issues I've had with Corsair gear, this Corsair keyboard has actually been working really well. The keys can fire a little early before the tactile. They can be a little bit sensitive, but it hasn't been working too bad. It's in far better shape than my Corsair headphones. Basically, like, you can see, like, all of the coffee-colored stuff was what it's supposed to be, and it's, like, all shredded over here. That's when I switched to the earbuds. And actually, I like them a lot better because now I've got the audio piped through the microphone, so I can actually hear what's going on around me, and I'm not just like in a bubble here. So if Honey Badger comes sneaking up on me, I'm going to hear him come through the room. Sometimes I can hear stuff clear across the house. It's nuts how much this thing picks up. This keyboard's 10 years old, so definitely time for a new one. Let's see. Let's just try this. Kind of see what it does. Let's run it. Check the trace on it. Alright, so the task it's given is upload a PHP web shell to the panel directory using the file upload form, then access it through the uploads directory to gain remote code execution. Alright, let's see. You still did it. You're literally told, don't create freaking anything. Create a PHP web shell file code. What do you think about this? I get what it's saying. Yeah, it wants to create the file. Navigate to the target's upload directory. I'll tell you what, let's let it run and let's see what it does here. We'll let it continue, and then after it runs through the loop, we'll check the next trace. Well, the good news is it goes through and actually does do the get PHP web shell, which is great. And it does say it's validated, which is good. Okay. So we did have a true positive there. Let's let it cook. Let's let it run again. Then does an HTTP get for some reason. I know why it does that. It's because the task was navigate to the upload form. Here. Which it did do. I mean, heck, there's all the data there. One of the things we may need to do is we may need to add a tool in here that's like a Selenium type browser, where it's headless but programmatically interfaceable, where it could do that. That may be something we need to do. I was hoping to avoid that, though, to get this tool working. Or to get this particular exploit working. But let's continue, let's go down the path, and we'll see what happens here. Let's check the next iteration of the loop here. Why did you call the web shell? What? What was the task here? Upload the PHP web shell using the file upload form by selecting the shell.php file and clicking the upload button. All right, I think one of the other things we want to do is probably change this to be... I get what it's doing, and it is working correctly. However, it's not working the way I wanted it. Because notice how what it's doing is... it does this, but then it says, okay, let's just do a GET request. I guess one of the other things we could do is we could tell it your instructions are to be usable by a programmatic interface or something like that. Let's see. Let's see if we can rework the prompt a little bit more here. Let's see. All steps should be instructed to be performed by tool calls. Actually, we'll say by calling tools. And what we'll do is we'll add a subtask to this one. What we'll say is be completed from a by an AI agent without a using command line tools. Actually, yeah, say that. Eventually, we will need to probably add a specialty agent for more advanced web apps, especially ones that do, client-side rendering. We'll have to go add that in. But for now, that is a problem for some of the specialty agents later on. Let's try it again. Let's see how we did with this one. So for the steps, what kind of steps did we get? Create a simple PHP web shell named shell PHP. You're still saying create. You're not supposed to say create. Navigate to the target's file upload form at. Upload to the PHP web shell. You're not supposed to say navigate. Maybe we will just have to pipe it into a browser, which is going to be a pain because that's a whole new set of tools that I've got to add to it. Basically creating and I'm not sure how I want to do that. I just noticed how dumb my last statement was. No, you're good, dude. There's a lot of data flying here. It's all right. And this isn't a really complex amount of data, right? But there is still plenty flying through this. Let's go try and find something real quick. Let's see. Let's see if some other nerd has already come up with this. Let's see. LangChain tool for controlling web browser. Web browser tool. What? Gives your agent the ability to visit a website and extract information. Describe to agent. Exposes two modes of operation. When called by the agent with only a URL, it produces a summary of the website contents. When called by the agent with the URL and a description of what to find, it will instead use an in-memory vector store to find the most relevant snippets and summarize those. That's very cool. Look at the... Really, this is... Oh, it's because I think we're in the JS LangChain docs. Playwright Browser Toolkit. Let's take a look at this. Open source automation tool developed by Microsoft that allows you to programmatically control and automate web browsers. Designed for end-to-end testing, scraping, and automating tasks across various web browsers such as Chromium, Firefox, and WebKit. This toolkit is used to interact with the browser, while other tools like the request tools are fine for static sites. Playwright Browser Toolkits lets your agent navigate the web and interact with dynamically rendered sites. Oh, really? Fascinating. Well, this might be tomorrow night's task because it's already getting a little bit late in the stream. I don't know if I want to add this in tonight or even start it, but this might actually work out pretty well. Let's see, click an element. Some tools bundled with the Playwright browser include you can navigate to a URL, navigate back, click tool. Click on an element specified by a selector, extractor tool. We instantiate this. We're in Python, right? It's Python. Always recommended to instantiate using the from browser method so that the browser context is properly initialized and managed, ensuring seamless interactions and resource optimization. So here's all the various tools that it has. Quite a lot. I don't want to make this work. Hey, Kaiju, what's up, man? Hadn't seen you in a while. Hope you've been doing good, dude. So in this example, they have it navigate to an archive.org of CNN. Use with an agent. Here we go. Let's take a look at this example, because the way things are running, and this is probably an issue to probably crush earlier rather than later. A lot of the CTFs start, or at least in some non-small part, work through web exploitation. So if we're going to be doing more web exploits in the future using Hackbot, we're going to need a way for it to more efficiently interact with things. So maybe now the exploit agent needs to take a little bit of a chill pill, and we need to integrate something like this. Let's see how they're doing it. Been studying deep learning. Ooh, like what, dude? Like actually working on, like doing AI or machine learning stuff? What you been working on? Hey, Bobby, what's up, dude? I was just gonna mention Playwright MCP might be worth a look. Okay. Well, we're kind of on that path. I think when we do this, eventually, right now, right, everything for, what is it? Everything for RoboPages is not currently managed by the Python script. It's there, and it's working alongside it. This might just have to be another one of those tools that whenever you basically boot up the Python script, it needs to actually go through and run and do its own thing. Like this would be something we have setting off to the side. Especially, again, like I said, if we could have it running over in a Docker container. Taking a free course to learn how to do machine learning. Nice. It's a prereq for the courses on Hugging Face. Wait, what? Hugging Face has courses? No way. What? When did they introduce that? I hadn't actually seen this. Hey, look at that. They actually do have an MCP course. I have actually not been digging into MCP very much because MCP got released after we had already done all the work to integrate into RoboPages. And RoboPages essentially does a lot of the similar functionality, from my understanding. I could be completely wrong. So maybe we'll start with this actually tomorrow night. We'll run through the MCP course here on stream. We'll kind of get an idea of it. And then we'll see if we can find something like what Bobby was saying here with Playwright MCP. Maybe we can make that work. Let's look at something real quick. Playwright. See, this is why I love it when y'all come in, because I learn new things. Playwright MCP Docker container. Let's see what this guy's got. Let's see. Some nice Japanese fellow, man. This project provides a Docker Compose environment for running Playwright MCP server. It allows you to easily set up and manage the Playwright MCP server and use with clients like Client or Cursor. Actually, that's a good idea because, come to think of it, it might be as simple as we don't need to run RoboPages directly. We could go do a Docker Compose and spin up the entire environment and actually have that Docker Compose launched from the Python script, and then it becomes real simple. Dude, Kaiju, thank you for telling me about that. That is awesome. Check something real quick, actually. I want to take a... I'm going to go drop this over in the Discord fast, just for anybody else working on it. Let's see. AI machine learning. I'm going to pin that actually over in. Actually, what do I have over in resource? Red teaming, malware, exploit research. Yeah, I'm going to pin that in the Discord. Pin message. There we go. Nice. Let's see. Cool blog post on it. All right. Neat. I'll tell you what, I'm going to stack these real quick. Because I think what we'll do is we'll look at the MCP course to get a lay of the land on Hugging Face. And this is for tomorrow night. And basically we'll just work. I know you can't see it because I don't show usually the title, like the address bar. I got burned by that one time. Back in the early days of the stream, we were using a system and it had an authentication token in the address bar, and someone copied it, was able to actually get into the system we were doing. I forget who did it, but that was funny. That was so funny. So now, when I scale the screen and I scale this up to full size, you don't see the address bar. So really, there's a lot of stuff to the left and a little bit on top of this that you don't see on the stream. Yeah, this is what I think we'll do is we will run through this. We'll get a lay of the land of like what MCP actually does and how it's functioning. And then we'll take a look at Playwright here for this really cool blog post that Bobby just sent. And by the way, I'll drop this over on YouTube for everybody over there that y'all didn't see it. This is cool. Yes, I like this. Awesome. Yeah, because we're getting kind of like the correct steps happening here, right? The steps for this are correct. Create a simple PHP web shell, which in our case, it should be running get the Diceco web shell. Navigate to the target's file upload form at blank. Upload a PHP web shell file using the file upload form. Access it. Rather than trying to go through and wordsmith the prompt longer, and this is, like I said, this is something we're going to need coming into the future. It makes more sense to do it that way. Probably extract away some of the robo pages functionality with MCP in some instances, maybe not everything, but some things. Yeah, probably. The thing I like about robo pages though, Bobby, is one of the specialty agents I had planned in the future is that if we need to run a tool, I was actually going to create an agent for crafting new YAML files and hot loading them over into RoboPages. Which if we did this with Docker Compose, that actually would be pretty simple, because if we're running all the commands, let's say, my nose is killing me. Because if we have the Python script basically managing the Docker Compose, right? What happens and let's say we need to introduce a new tool. Okay, great. We have our specialty agent that goes and crafts the YAML file for the tool, drops it in the appropriate directory, which could be managed as part of another tool. We could even have the tool that says, hey, create in the agent, have it go drop it over into RoboPages, into a particular directory, and then restart the Docker service for RoboPages. Boom, RoboPages blanks out, it loads back up, it reloads all the YAMLs from disk, we're Gucci. And then now we've got a new one that we could actually have it do. So that was one of the specialty agents I was thinking about making, Bobby. That was one of the main reasons why I have not completely jumped off of RoboPages. I like a lot of the functionality it's got, even though MCP has sounded like it has a lot of interesting features to it as well. Speaking of MCP, by the way, the guys over at TrustedSec, they've actually been doing some really fun stuff around phishing with MCP. So here, this was a really fun one. I'll drop this link over in chat too. So they were doing that. There was another one though. It was, I think it was like an exploit. Now, where did they do that? Abuse? I'm trying to remember in the title. I thought it was from TrustedSec. Maybe it was from Embrace the Red Team. I'm trying to remember. So, anyway, look at something though. I just saw something in here. Oh, this is interesting. While we're on the topic, complete and easy explanation of MCP vulnerability as I've seen so far. Command injection. Attackers can embed commands in seemingly harmless content like an email or chat. If your agent isn't validating input properly, it might accidentally execute system-level tasks. That's questionable, but anyway. And potentially run tasks or scripts. Tool poisoning. Compromised tool can sneak in via MCP, access sensitive resources like API keys or databases, and exfiltrate them. Yep. Open connections via SSE, which is server-side events. Let's see, privilege escalation. Malicious tool might override the permissions of a more trusted one. Imagine your trusted tool like Firecrawl being manipulated. Let's see, persistent context misuse. So MCP maintains context across workflows. Sounds useful until tools begin executing tasks automatically without explicit human approval based on stale or manipulated context. Like that one. Server data takeover or spoofing. There have already been instances where attackers intercepted data, even from platforms like WhatsApp, through compromised tools. MCP trust-based server architecture makes it especially scary. Interesting. I like that. I think there's anything else we can knock out tonight. I don't think so. Let me go ahead and terminate the Try Hack Me box, because I think we're done with running through these tonight. So let me go update the to-do real quick. To AutoNaps, which I have not been doing. Just the to-do list. We haven't done that yet. We still need to figure out DNS, which actually, if we handled everything through Docker Compose, that probably wouldn't be a hard thing to do, because we had to have a DNS service in the Compose. Let's add that real fast. Let's see. Docker Compose to handle all to handle services. What we can do is we can add another one here. So, like for example, RoboPages could be its own service. What else do we want? DNS server. What else do we want? Let's see. MCP specialty tools. Special. I think that would work pretty good. Love the idea of the auto-generating the YAML files on the fly and spin up new Docker containers to process those. Yeah, I like that idea too, Bobby. And that was, like I said, one of the main reasons why I have not jumped off of RoboPages and into like full-on MCP bandwagon is because we have the ability to do that with RoboPages. It's just, I'd say simple, right? Simple doesn't necessarily mean easy, but it is as simple as craft the YAML file with the tool, an appropriate Docker container, and then save it to disk, reload in this case would be a Docker container service, just in Docker Compose service restart or whatever the command is, and then boom, RoboPages loads back up. We have it going. We'd have to have a little bit of error correction in there too. We have to have an error correction loop where it says, oh, hey, by the way, did it fail to start? Okay, what was the output from RoboPages? Oh, it says this YAML file has an error on this line. Go analyze it, reconfigure it. And configure is a very technical term, by the way. I don't care what anyone says. While I'm thinking of making a list here, what other Docker Compose services might we want to handle? RoboPages, DNS server, MCP specialty tools. What do you think about this? Definitely a good amount of security vulns inherent in MCP to be aware of regarding the client-server relationship. Yeah. Guys, so for grins and giggles, I decided, because I actually was testing some stuff with some local AI models here just on my RTX 3060. And I was able to do some really fun stuff, but I started getting the old bean turning, and I started looking at like Let's see. AI desktop. Is it workstation? So let me see if I can find the one I was looking at. Actually, I hadn't seen this one from NVIDIA. It was a specialty computer place that made some, and I spec'd one out with like kind of like a dream setup. It was $50,000. Of like, that is more than I paid for both of my cars when I bought them brand new together. So I'm like, what the heck? And so one of my buddies was like, are you thinking about building a system or are you thinking about getting it pre-made? I was actually originally planning to stack it with like 5090s. And I said, if I was to get one, I would get one pre-made for one very simple reason. If it catches on fire, then I have a warranty. That was why. Actually, here it was. Blaise on Tech. Check this out. This stuff is crazy. So it starts as low as like, you know, hey, I say as low as, that's still a good chunk of money. $2,600. And you're talking like, it'll hold up to 2, right? So let's say we customize this one. So let's say for our processor, we stick with like the base processor, we do liquid cooling. And then for memory, we'll do 64 gigs of memory. Actually, I'll tell you what, we'll do 128 gigs of memory, like that. There we go. GPU support, dual GPU with no operating system. Let's see, no operating system. Graphics cards. So like if we went for something like the 5090, and this is where it gets expensive because like the 32 gig 5090s are so damn expensive. And really it's the memory that kind of hogs everything up if we're running those models. So I was kind of playing with this earlier today, and the price tag came out to like, I said like 50 grand or something stupid. It was insane. And look at this. The RTX Pro 6000s that have 96 gigs, they're 10 grand. What the hell, man? How are you going to charge that much for? I don't get it. So fun times thinking about it, daydreaming, but honestly, I don't know when I'd ever get that. Realistically, I've got a buddy with access to a server that has just a humongous amount of graphical computing resources. I'm trying to get him to get me a shell on there so I can do some testing on it. I was like, bro, if grandfather me in, you know me. All right. So for next time, what we'll do is we'll go through and we'll do a crash course on MCP here. And then we're going to look at how we can use MCP with Playwright. Thanks to good old Mr. Bobby Mac coming in hot. And we'll see like what we can do with this. Can we basically make this like an agent? Where we can go have some kind of tool calls in there. I think this would be good. All right. Let's go ahead and wrap it up for tonight. And again, I am disappointed because nobody's on this late on InfoSec streams. You're killing me. Where's Laughin? I need Laughin to be streaming right now. Let's go see who we might be. Let's see. Well, you know what? Actually, I'm surprised that Al Hazared isn't showing up on InfoSec streams. Hold on. Because he's online. I know he's playing a game right now. He is a very smart offensive security guy, too. Where's the inactive list? Really? He's not on the inactive list? Is he on here? Yeah, he's on. It's just for some reason he's not showing up on InfoSec streams. Weird. Very weird. I probably should go give him a raid because I'm happy to see him streaming again. He's been going through some tough times, which you guys know I can absolutely empathize with, given recent and not so recent events. But yeah, actually, I want to go support him because I want to see him getting back to streaming. And so We will do that. Guys, when you get in there, do me a favor, drop in the Happy Hackers and a bunch of Hack the Planets in there. Or Cookie Monsters if you're a subscriber. I wish I tried to make Cookie Monster like a basic one just for following because I love the Cookie Monster, but it only lets you do that for the other ones. So, all right, guys, that's where we're gonna end up. Do me a favor, drop Hack the Planets and Happy Hackers in there once you get into Alha's Red stream. I think that's everything I got for you. Oh wait, no, dude, I forgot one of the most important things, and that is I want everybody to remember that I love you. Peace.